Thank you, everyone, for joining this webinar today, hosted by the International Telecommunications Society, TELUS Communications, and the Monk School of Global Affairs and Public Policy at the University of Toronto. Before we begin, I do want to acknowledge the land on which the University of Toronto operates. It has, for thousands of years, been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit. And we're grateful to be able to work and to play and to live and to be together on this little part of Turtle Island. Today, we have the distinct pleasure of speaking with Daron Acemoglu, Institute Professor in Economics at the Massachusetts Institute of Technology, and co-author with Simon Johnson of Power and Progress, Our 1,000-Year Struggle Over Technology and Prosperity. Daron will, of course, set the stage for this discussion, and following his talk, Professor Sherry Eli from the Monk School and the Department of Economics at the University of Toronto will moderate a Q&A session. Before we dive in, it is my pleasure to welcome Stephen Schmidt, who is the Vice President of Telecom Policy and Chief Regulatory Legal Counsel at TELUS Communications and Chair of the International Telecommunications Society. Stephen, the floor is yours.
Thank you, Peter. Thank you, Peter, and good morning to all. It's a privilege to welcome you on behalf of the ITS, International Telecommunications Society, a global forum where academic, government, and industry communities meet to discuss pressing policy questions at the intersection of technology, law, and social change. And today is a great example of that. I extend my deep gratitude to the Monk School and Drs. Lowen and Eli. Thank you for your amazing collaboration, friendship, and incredible promotional acumen. As Peter noted, today we have with us Professor Daron Acemoglu, an Institute Professor of Economics at MIT. He has distinguished himself in numerous ways, including being the third most cited economist in the world, being the recipient of the John Bates Clark Medal in 2005 as one of the US's most promising economists under 40. And he continues to build on a career-long exploration of how institutions and technologies interact to shape society and economy. There has been a traditional conception or position that technological change and progress, particularly in the case of general purpose technologies, improve productivity and as a result improve living standards over time. And while such technologies can improve the quality of life long-term, we have to be aware of and address medium-term challenges or near-term challenges such as labor market disruptions, and ensure ultimately that the benefits of these general purpose technologies are widely shared. By viewing technology through a historical lens, we can better understand and manage technological revolutions. We can better support worker reskilling and enhance social programs, and we can harness general purpose technologies for a more inclusive future. In Power and Progress, as noted, authored with Simon Johnson, Professor Acemoglu examines the historical impacts and technological revolutions, offering crucial lessons to navigate today and tomorrow's challenges, including the challenges of AI-driven automation. So thank you to everyone for being here. Thank you, Professor Acemoglu. Over to you. We're looking forward.
Well, thank you very much, Stephen. Thank you, Peter and Sherry, for hosting me here. And it's my distinct pleasure to be able to share some of the ideas from my recent book with Simon Johnson. So without further ado, let me share my screen and get started. So the reason why Simon and I wrote this book is because we think that we are at the cusp of continuing and major changes in technology that have sweeping implications for society, including most recently AI. But some of the most important questions that we believe are quite clear in history are not being asked, or at least are not being emphasized. And those are about who controls the technology and how the control of technology and how it's going to be developed and leveraged will determine who will benefit and who will suffer the possible negative consequences. Part of the reason why these questions don't get asked is because there is a deep-rooted optimism about technologies in the United States and many other corners. Journalists, economists, policymakers, certainly technologists believe that technology can be a solution to many of our social problems. If there are some rough edges, we can sort them out later. But there is also a major sort of idea from economics, which has become common wisdom in a lot of these discussions. And it's something Simon and I call the productivity bandwagon. The sort of idea that there are powerful market forces that ensure pretty much everybody will benefit from technological improvements. And the idea is that once you improve technology, a very important set of consequences from this will be through productivity, meaning that we increase our capability to produce more output, higher quality output with the same amount of inputs. And then these productivity increases create a bandwagon that ultimately pull workers together. And workers also benefiting is critical because, in fact, most of us still earn our living in the labor market. So if there wasn't a powerful market or other process that led to higher wages from technological improvements, it will be very hard to build shared prosperity, and it will be very hard to say that we are really leveraging these technologies for common good. Unfortunately, Simon and I think that both economic theory and history are more complex than this productivity bandwagon caricaturization. In particular, it depends both on the nature of technology and the nature of social power, political power, labor market power, in a way that I'm going to try to explain. So if you want to find examples in history where productivity improvements led by technological breakthroughs became the foundation of shared prosperity, you can do so. But you can also find examples where the opposite or something very different has happened. So here in this slide, I start that discussion by showing two instances of truly revolutionary technological change. One in the medieval age, where the windmills were one of the most important technological advances that completely changed the organization of society and organization of production, with significant improvements in productivity in a number of tasks. And the other one is Eli Whitney's cotton gin, which turned the U.S. South from being essentially an economic backwater to one of the most important parts of the world economy, the largest supplier of cotton to the world when the British Industrial Revolution depended on the supply of cotton. And fabulous fortunes were made on the basis of the ability to grow cotton enabled by the cotton gin, which could then be used for cleaning that cotton. But both of these examples are instances where the workers, the people who were actually engaged in production, did not benefit from it. So the workers who were engaged in agricultural work, the majority of the population in the medieval period, did not see much improvements in their living standards. In fact, there may have been some worsening during the long period during which the social organization changed associated with the windmills. And in the context of the Eli Whitney's cotton gin, or the cotton gins that other people around the same time introduced as well, the main producers of cotton were Black enslaved people, and their living standards actually most likely declined because they were moved into the deep South, working conditions worsened, working hours lengthened, coercion increased. And of course, you could immediately see what's common between these two episodes. They weren't embedded in anything approaching competitive labor markets. They were in coercive environments where the landlords in the medieval case and plantation owners in the case of the cotton gin had disproportionate power, and were using that coercive capacity in order to shape the work experiences and wages of the workers. Under these circumstances, I think it's quite obvious that we shouldn't expect an unconditional productivity bandwagon. Productivity may increase, but whoever controls the means of coercion may decide not to share any of that, or in fact may intensify coercion and worsen the situation of the working people. A more common example that people who believe in the beneficent effects of technology give is the British Industrial Revolution. But in fact, the British Industrial Revolution is also more complex and nuanced. First of all, the story that British Industrial Revolution seamlessly led to a process of economic growth that benefited everybody couldn't be further from the truth. The first 90 years or so of the British Industrial Revolution, starting from around 1750, were very harsh times. The living conditions of the majority of the population worsened, together with longer working hours, probably stagnant real income, so therefore declining real hourly wages, and working conditions became much more severe, much more disciplinarian in the newly emerging factories. The situation in the British Industrial Revolution is very interesting for two other reasons. First of all, the reason why people have a more optimistic take on the British Industrial Revolution is because from 1840 onwards, the nature of technological change and certain other social and economic and political conditions started changing. And during that process, wages started increasing as well. So by the beginning of the 20th century, the British Industrial Revolution did deliver some wage growth, but this was very delayed, and I'll argue was not automatic in any inevitable in any sense. And second, while notions of power relations played an important role in the context of the British Industrial Revolution as well, this episode also emphasizes the nature of technology. What the British Industrial Revolution signified was the introduction of new machinery, which was completely sort of transformative. But at the same time, this machinery was used for what we today call automation, meaning for replacing tasks previously performed by labor. And as machines displaced labor, average productivity did increase, exactly like the productivity bandwagon, like the productivity bandwagon indicates, but the benefits did not necessarily flow to workers. And that's a very important idea that, in some sense, is sometimes misunderstood. And so let me take 2 minutes to explain the idea. In fact, the basic economic theory doesn't say that as productivity increases, workers should benefit. When we say productivity increases, what we normally refer to, and that's what journalists and statisticians measure in the data, is average productivity, how much output you're producing, for example, relative to the number of hours of work. But economic theory is very clear that even under idealized circumstances, workers should be paid according to their contribution to production or according to marginal productivity. It's only under some fortuitous circumstances that average productivity should immediately translate into an increase in marginal productivity. And automation is exactly the type of technological change that does not guarantee that average productivity increases should translate into marginal productivity rises. Perhaps the best way of understanding that is the sort of the humorous story, which is often ascribed to many different people. So let me not get into who actually said it. But the story is that the factory of the future will have 2 employees, a man and a dog. The man is there to feed the dog, and the dog is there to make sure that the man doesn't touch the modern equipment. So that's some people's utopia. If you really are dreaming of a workerless factory, that's what you're aiming for. But it's also humorous and dystopian because, what will people do if, in fact, we go to a factory like that? And the other useful point about this story is that, of course, it highlights that we can increase average productivity with better and better machinery in a factory of this sort, but no employer will rush out to hire more men and more dogs because, the humorous part of it is that they weren't really needed anyway. So their marginal productivity, their contribution to production wasn't very high. So automation, by displacing workers, increases average productivity while at the same time driving a bigger wedge between marginal and average productivity, or in fact, even reducing average productivity. So you might think all of this is in history. Today, we don't live in a society in which there is naked coercion. And you might think that today we live in a more enlightened society where technologies are going to make sure that new improvements in technological capabilities will make workers more productive as well. Well, yes and no. No, yes, in the sense that indeed the 20th century has something that previous epochs have rarely experienced, which is a extended period of shared prosperity in which real wages increase for many workers at the same time. So here I'm giving a glimpse of that by showing the real wages, inflation-adjusted wages of workers sorted into 10 demographic groups, men and women, and workers with postgraduate degrees, graduate but no postgraduate education, associate degrees, high school education, and without less than high school education. And the picture from the late 1940s to the 1960s is also similar, but I'm starting from 1963 for data availability reasons. You see all of these curves are on top of each other. All of these groups are benefiting from economic growth in parallel, in tandem. In fact, it's very, very rapid economic growth here. You're seeing all of these curves rise together. Their rate of increase is really staggering, 2.5% a year in real terms. This was a period in which productivity grew rapidly, and productivity growth led to as rapid growth in real wages. But from 1980 onwards, you see a sea change, something very different. Inequality is increasing. The gap between the top and the bottom, the more educated and less educated, is widening. But even more strikingly, low education workers, especially men, are experiencing very sharp declines in their real earnings. So this is a period where productivity is growing. Some people are benefiting a lot, but about half of the population is not benefiting from economic growth, and some of them are experiencing declines in their real wages. This is a distinctively US phenomenon. Inequality increases in other countries. That's not just a US phenomenon, but this bottom of the distribution collapsing is specific to the US. US was already more unequal in the 1980s and then became very, very unequal. Several other countries have also become more unequal, but without perhaps as much of a decline at the bottom. But the kind of forces that are impacting the labor market have some commonality across nations. So in order to understand what went on in the 1950s and 60s and early 70s, perhaps also in the second half of the 19th century, early part of the 20th century, we need to understand when the productivity bandwagon works and why it collapsed after around 1980. And I think the story of the productivity bandwagon is very much related to the two things I emphasized already. You need a type of technology that doesn't just automate and sideline workers. And you need workers to have voice and power in wage setting and work conditions so that they get a fair share of the increase in productivity. What is it that would ensure workers are not sidelined in the production process? Here I try to illustrate that with the example of a Ford Motor Factory. Henry Ford was a leader in the introduction of mass production, and he was very determined to actually automate work. But if you actually look at the Ford Motor Company's revolutionary plans, while they were really at the forefront of introducing interchangeable parts, then assembly parts, decentralized electricity sources for machinery to perform more tasks, they were also doing something else. They were also introducing more technical tasks, more capabilities for workers to go along with the new technology. So here you're seeing the more advanced equipment, but at the same time, workers quite heavily involved in the production process. And that's really the tip of the iceberg, because what was really revolutionary about the Ford Motor Factory was that it was an engineering breakthrough. So at the same time, you have improvements in design, maintenance, cost control, rapid introduction of new machinery and reorganization of the plant. So it is this sort of aspect that the Ford Motor Factory sort of perhaps accidentally signifies, but at the same time, you see it in common in the 1940s, 50s, 60s in the United States and in the rest of the industrialized world. And this is what we capture with the idea of new tasks. So essentially, production technologies are not just automating work, but they're also introducing new tasks for workers to do, so that as workers lose some of the tasks to automation, they are being allocated to new activities where their marginal productivity, their meaningful contribution to production is even higher. So why did things go wrong in the digital age? Well, this is the equivalent for car factory today. You see even more fancy and nicer colored equipment, but what you don't see are the workers. So you have done the automation here, but you're not at the same time creating new tasks. So to a first approximation, I would say part of the reason why shared prosperity has collapsed in the United States and several other industrialized nations is because we have used digital technologies too much for automation and not enough for creating new tasks. Now, of course, something as transformative as the huge increase in inequality in the United States since 1980 has many causes, and some of you may have already information on the role of globalization or changes in deregulation and so on and so forth. But my own research highlights that, in fact, automation, how we have used digital technologies was absolutely central. So here, to summarize that, I'm showing a chart from my paper with Pasquale Restrepo. And what I'm doing here is that I'm shifting the focus from the 10 demographic groups that I showed you earlier on to more detailed demographic groups distinguished by gender, education, age, and ethnicity, and zeroing in on that critical period where inequality was increasing from 1980 to just before the COVID crisis. So I'm showing here is the cumulative change in the real wages of different demographic groups. Here is the zero line, and you see the same picture that I emphasized earlier on. About half of these circles, especially many big circles which signify low education groups, are actually below the zero line, meaning that they are not enjoying real wage growth. They are experiencing real wage declines. More important is the horizontal axis, which is Pasquale Restrepo and my measure of the extent of automation impacting a demographic group. Roughly speaking, is the share of tasks that a demographic group used to perform in 1980 that have since been automated. So a number like 20% means that these high school graduate demographic groups have lost about 20% of the tasks that they used to perform in 1980 since then to digital technology. And you see a very striking and strong relationship. In particular, pretty much all of these declining real wages, this real departure from shared prosperity, is intimately linked to high extent of automation without new task compensatory changes. But of course, as I have emphasized, power is important as well. And power is important both because it shapes who gains the benefit, who gets the benefits from productivity gains, and also the technological choices. How we use digital technologies is very much conditioned on how we organize society, who sets the visions, who sets the agenda for technologies and for companies. And here, I think the 1980s have seen two parallel and self-reinforcing trends. One related to the decline of union power. This has many causes, but many people see it as symbolically related to or accelerating after Ronald Reagan's firing of the professional air traffic controllers strike right after he came to power. The other one, perhaps more interesting for an economist audience, is that actually economists' ideas may have contributed to this as well. Milton Friedman, a very, very important, very creative economist, but his most important writing is not in economics journals and related to deep technical issues, but it's something he wrote in the New York Review of Books, New York Times Magazine, where he argued the only social responsibility of business is to increase its profits. So he was enshrining the idea that businesses should ruthlessly cut costs, meaning wages, because that was what they were supposed to do, and that's what their shareholders would appreciate, and they were there for their shareholders anyway. So if you, of course, justify that sort of managerial behavior, you're going to get two types of implications out of that. One is managers are going to resist any kind of wage increases, and there's a lot of evidence that they've done so. And second, they're going to be particularly interested in schemes to reduce labor costs, and among those, automation, investing more and more in software and machinery in order to reduce the payments to labor becomes particularly attractive. Now, of course, none of this would make sense if you don't have the tools for automation. That's where the computer science revolution and then subsequently the AI revolution came in. And computers are what economists call general purpose technologies. You can use them for many, many different things. In fact, many people believe that you could use them for increasing worker productivity. But a very influential line, going back to the origins of the computer science discipline, goes back to this brilliant mathematician Alan Turing and his imitation game, or the Turing test that you may have seen either in newspapers or in the imitation game movie, Hollywood movie, is that computers should strive and can ultimately achieve what Alan Turing called autonomous machine intelligence. Machine intelligence meaning capabilities that are similar to the intelligent functioning of the human analytical capabilities, and autonomous meaning that that would be self-acting. This vision of computers ultimately becoming as good as humans and taking tasks from humans was then swallowed hook, line, and sinker by the AI community. The field, for example, which can be traced back to a conference in 1956 where the field of artificial intelligence was christened, was very much in this mold of we're going to create machines that are going to do everything better than humans, and then they're going to take over tasks from humans. Once you have this as your guiding principle in the tech industry, it becomes very natural that you're going to put more and more of your energy to creating digital tools that can automate work. And artificial intelligence borrowed or built on the same sort of ideological vision of where the field should go. And in this sense, who controls AI, which I emphasized at the beginning, is inseparable from what are the guiding principles of the people who are shaping AI or who are controlling AI. And here, the irony is that, in fact, this is not the only way in which we could have conceptualized AI, and it's certainly not the only way that leading thinkers at the time conceptualized computers. So as early as Alan Turing was articulating his ideas about ultimate computation machines or universal Turing machines doing everything human mind can do, there were others like Norbert Wiener at MIT writing about how automation was potentially dangerous and there was a better way of using machines to complement human abilities. And the ironic part of this is that many of the most important computer breakthroughs actually came out of this vision. So many of the technologies we take for granted today, the computer mouse, hyperlink, hypertext, machine-driven menu-driven computers, came out of a human-machine complementary research agenda, for example, led by an engineer called Douglas Engelbart and his students. The ARPANET and then the later internet came out of a research agenda led by another person with the same sort of ideas who talked of human-machine symbiosis, J.C.R. Licklider. And the sort of irony deepens because many of the ideas that people like Wiener, Engelbart, and Licklider had become much more relevant in the age of AI, because AI has the capacity to be a real informational tool for workers. The problem, however, is that that's not how we're using AI. If you double down on AI as an automation technology, you're not going to get these benefits. You're not going to get these human complementarities. You're not going to make workers more productive. And that is not good for shared prosperity. But in fact, it's not even good for productivity, because if you go into excessive emphasis on automation, what you're going to do is you're going to use AI, as you've done with digital technologies, for automating things that humans are quite good at. Humans are very good at things that involve social skills and human interactions. Many of the tasks that involve customer service, interacting with other humans, helping them, have already started being automated. And it's no surprise that we are not seeing much productivity benefits, because we are using AI for things that it shouldn't be used. Instead of helping humans becoming better informed and more productive, we are using it excessively for automation. And in fact, this is not an unfamiliar story, because the computer revolution itself hasn't delivered in terms of the productivity promises that people were expecting at the time, because it wasn't always used in the right way. And the problem, in fact, is deeper than that, because we are using many of these informational tools, not just for automating work, but we are also using them for changing the way we communicate and we organize our society. And one implication of this, which is already visible from social media, is that we're creating growing monopolization of information. So who controls AI is very much about who controls information. Now, everybody is familiar, and at least in the West, not so happy about the trends in China and some other authoritarian countries where informational tools, including AI, are being used for intensifying monitoring. So these are, for example, the social credit system's first implementation, where you have to check your social credit system and get a permission before you can buy a train ticket. The whole censorship system that has intensified in China is a testament to that. But generally, there is a very different take on what China is doing with information versus what the US is doing for information. But actually, when you think about it, there are more parallels between China and the US. In China, yes, it is the Communist Party and the government that controls information and that guides tech companies. And in the United States, it's Facebook, Google, Amazon, and other companies that have that big control over information. But it doesn't matter so much who's controlling information if there is a monopoly of information. And I think the problem of social media, where we are very much at the beginning of it, is a warning sign about what happens when you have this monopolized control of information. Somebody is going to decide what you see, and somebody is going to have to come up with a way of monetizing it. And that way of monetizing it is not very good for democratic discourse, and it's not very good for mental health, as we have seen from social media. The chances are that AI is going to deepen these tensions. It was more than half a century ago that the political scientist Hannah Arendt, philosopher, political scientist, sort of foresaw the real danger, which is if everybody lies to you, the danger is that nobody believes anything any longer. And if nobody believes anything any longer in a polarized environment without shared understanding, I think it becomes very difficult to have democracy. And if you don't have democracy, I think the danger is that we give up all sorts of correction mechanisms about the future of technology. So in other words, what I am outlining here is that AI, just like other general purpose technologies, can be used for many things, and there are several very beneficial uses of it in a way where we can use AI in a pro-worker way. We can use it for a pro-democracy way to improve communication between people, build new democratic platforms, make citizens more informed. Or we can do the opposite. We can automate work, sideline workers, use AI as a manipulative technology. And I think the issue is that I don't think there's any guarantee that if we leave AI in the hands of the most hubristic tech leaders, that the right direction is going to be found. So how can we find it? Well, I think it's a much better bet to rely on the democratic process, but the issue is that AI itself may be undermining the democratic process. What we can do, therefore, is find the source of countervailing powers. In the past, I think when there was issues of corporations, individuals, or even other leaders becoming more powerful, three sources of countervailing powers have been very important. The democratic process, ultimately through regulation and other means, consumer or civil society organization, again, both directly by putting pressure on companies and through regulation, and the worker movement. Today, I think all three of those are getting weaker, but again, this is not a process that is preordained. It's how we take part in the democratic process, how civil society organizations engage, and how workers do or do not have the ability to organize that are going to be critical. And in all of these cases, I think there are important margins of choice. In all of this, I think the imperative from the vantage point of my research and the book that I have written with Simon Johnson is that it is imperative to redirect technological change, meaning it's not just that you need a consumer protection like Ralph Nader's in order to make sure cars are not unsafe, or unions to make sure that we can implement minimum wages, but much more importantly, we want social power to be more distributed more equally in order to redirect technological change. New tasks for greater worker marginal productivity, better information for workers and human decision workers, greater worker autonomy, and empowering citizens. And again, the irony is that many people thought that computers were going to do this exactly. I could put many pictures here. I put the picture of Ted Nelson from the 1970s, but their view of what computers were capable of doing never became a reality, precisely because the vision of technologies as a automation device led by large companies took over the process. And the final thing I want to point out is that this agenda of redirection of technological change is not a pure dream. It has happened many times in history. The direction of technology, especially for things like computer technology, are very, very malleable. And one example where we see a modicum of civil society action, government regulation, and democratic process redirecting technological change over the last 20 years is in the energy sector, where despite the overwhelming evidence for climate change, in as recently as 2000s, there wasn't much that you could do because the alternative sources of energy, solar power, solar photovoltaic cells, offshore wind, onshore wind, they were all prohibitively expensive. And since over the last 20 years, we've seen a tremendous drop in those costs, and they've become competitive with fossil fuel costs. How? Well, there has been a redirection of technological change in response to these sorts of outside pressures against the direction that the energy sector itself would have taken otherwise. So I think the idea that redirection of technological change can happen is not just a dream, and I think it is even more imperative when it comes to how we will use AI, that this sort of redirection of technological change is on the agenda. Thank you.
Thank you, Daron, for this fascinating talk. I have so many questions, but before we begin, I would like to remind the audience that we want to hear from you, and please submit your questions using the Zoom Q&A field below, and we will get to as many of them as we can. Let me start off by asking you, from your talk, it sounds like economists can't solve this problem alone, that we need political scientists, we need a political movement. Given that civic engagement among those under 40 appears to be at an all-time low in the United States, how do we implement this? So in previous generations, we had events, specifically wars, that unified whole generations. We don't have that today. Younger people are alone, in part because of social media, express feeling politically inert. Do you have thoughts on this?
Well, I mean, I think that's exactly part of what I was trying to point out with social media, that in fact, social media has made democratic citizenship harder already. I don't think we can blame just social media. There are other forces at work, including, I think, greater disappointment and grievances among some parts of the population about what democracy has or has not delivered. But I think social media has been a major force, and it creates a much more atomized society and polarized society in which democratic action becomes harder. But I think it's not impossible. At the end of the day, what's true for economic choice, I think, is doubly true for political choice. How we live our political lives is very much a choice that we make. It's subject to human agency. And I think if people become convinced that there are important issues at stake, it could change. But I completely agree, it's going to be more difficult to change. On the other hand, I think if you look at many important periods in which political participation became more heightened and led to social change, a decade before then, you wouldn't necessarily have anticipated that. During the progressive era, for example, I think many people thought that any type of influence on the US political system would have been impossible because the US political system had fewer democratic elements at the time. Senators who were not even directly elected were generally viewed as completely beholden to moneyed interests, and the presidential system wasn't working in an effective way either. But the progressive movement was very successful in bringing many different parts of society together and unleashing a process of build-up of pressure on politicians that led to fundamental reforms, and that fundamental reforms that really undercut the most powerful corporations that humanity had seen until that point. So I wouldn't be, Pollyanna-ish and say, oh yeah, this is around the corner, but I wouldn't also rule it out. And I think we have to be hopeful in order to be able to sort of work towards something better.
So another question we have is, given advancements in AI, what does the profession of economics look like in the next 10 to 20 years?
Well, I think in economics, we're actually quite fortunate because I'm sure people will say that some people will in the industry are thinking of artificial general intelligence, which I think is the apex of the kind of dream or nightmare of machines replacing humans. But I think the field of economics, as many other social sciences, are relatively safe from AI at the moment. And on the other hand, AI, and especially, I think AI is a misnomer here, machine learning techniques are introducing many new tools for economists to use. So the number of papers, for example, using large data sets has increased. The number of papers that economists and the number of research questions that economists can tackle by using natural language processing is expanding. So I think we are in the fortunate part where we can use many of these tools in ways that are complementary to our skills. Unfortunately, the rest of the population isn't in the same boat.
Another question we have here, in some of what you discussed in earlier slides, you show that technological change can benefit different classes of workers at different times in history. In the middle of the 20th century in the US, unskilled labor could command a relatively high wage. As you said, by contrast, today the returns to skill are high. And a segment of workers, white-collar workers, are benefiting. So these new technologies have enabled white-collar workers in younger generations to become sort of more productive, but also quiet quitters, quiet vacationers. So it's allowed for flexibility in working hours. That's benefited parents of young children. So I guess in your view, what's going to happen to this this upper middle class of workers going forward? Are they going to suffer the same fate as blue collar workers faced in the 80s?
Well, it's a very, very interesting question. I think the question already has many elements of the answer that I see as right in itself. There are views within social sciences from time to time that there is something inevitable about technological change, that, for example, it will be skill biased, that it will always increase the contribution of skilled workers more than those of unskilled workers. And I think the history of technology shows that's not generally true. New technologies can improve the capabilities of unskilled workers by introducing new tools for unskilled workers, or it can replace skilled workers. And I think AI is sometimes touted as a technology that's going to be more equalizing because it's going to replace more analytical work, more clerical work. If you look at the reality, there is some of that potential, but the equalizing effects of AI are much exaggerated. So if you look at the types of jobs that are truly automatable using AI right now, they are at the very low end of the clerical scale. It's not, CEOs are not going to be automated, C-suite is not going to be automated. But it might, depending on how it goes, it might put more pressure on the middle class. my recent work suggests that, capabilities of AI are not there, that we should see that kind of truly disruptive change within the next, 10 years. But beyond 10 years, if the tech industry goes all into automation, it might start having more effects on the sort of the professional class. And I think that is, again, in my opinion, a missed opportunity, because we can use AI in a way that's much more complementary to the professional class. The irony of our age is that information is abundant. You can find anything you want on the web, but useful information is scarce. So if you provide professional workers with much better information that's context dependent, that's relevant for the real task that they're performing at the moment, it can actually make them more productive, and it can increase their ability to perform more sophisticated tasks. And moreover, once you see that logic for professional workers, you see that it actually applies for manual workers as well. There is, I would say, even greater room for making better electricians and better plumbers and better carpenters by providing new and capable informational tools to these craft workers. So the issue is, again, we may be bypassing all of these potential opportunities by emphasizing artificial general intelligence and techno-optimistic account that AI is going to benefit all of us too much, and empowering people like Sam Altman and Elon Musk, rather than sort of a more sort of a democratic process of technological trajectory.
Let me switch now to the Canadian context. What kind of policies does a country like Canada, which has enacted a fair amount of legislation to protect workers and has a wide social safety net, what does Canada need to add to its slate?
That's a great question. And I think one thing that Canada has that the US doesn't have is actually protection of workers. One of the applications of these technologies that's very worrying, that you see both in the United States and in China and in some other developing nations, is that they are extremely intrusive, and they wear down worker autonomy and can enable much greater pace of work and much more dangerous type of work for workers because of the more intensified surveillance and monitoring. And I think places like Canada have better guardrails against that. But if you go back to the agenda that I was trying to summarize, I think the most important part of it is redirecting technological change. And redirecting technological change is not something that any single country can do by itself, although the United States can be the most important center of it. So I think Canada can have a role in this, but it is critically going to depend on the multinational context. So how can countries like Canada, the European Union, the UK work with the United States in choosing a different direction of technological change? So that necessarily requires some sort of change in the United States. And here, the US is really the odd man out. If you look at all other countries that are broadly near the frontier of AI, China, European Union, the UK, Canada, they all have much better regulations than the US. So the US is the one where regulatory environment is essentially very weak, and any kind of control over the very powerful tech companies is completely missing. So I think that is going to be the big bottleneck.
That leads me to the next question. It sounds like there's a trade-off between being a sort of slow adopter or slower adopter of new technologies, which is the case for a country like Canada, versus being the creator or inventor of these new technologies, which is the case for the US. Have you thought about what is the right sort of how to deal with that kind of trade-off? On the one hand, you want to encourage innovation. On the other hand, it sounds like from what you're saying that the US suffers a penalty for being the innovator.
Well, I mean, I think that indirectly, yes. And I think if we have the right direction of technological change, and technological change is going to benefit everybody, yes, of course, we want to go as fast as possible. But if you are going in the wrong direction, going more in that direction would be both directly and indirectly costly. Directly costly because we are creating damage, and indirectly costly because reversing it is going to be harder. It's the same thing with fossil fuels. If we, imagine that we're back in the 2000s and we're having the same discussion saying, well, do we need another $1 billion to produce even more powerful internal combustion engines? And the tech line is, yeah, of course, that's better technology. Better technology is always better. But no, I think what we needed to do in the 2000s, which we did to some extent, is reduce investments in fossil fuel technologies and increase investments in solar, wind, and other renewables. So I think it's the same situation here. And the issue is, of course, who were the companies or who were the people who were advocating all in fossil fuel technologies? They were the big energy companies in the United States and in Europe. So who are the people who are advocating for all in to another $7 trillion investment in GPU capacity in order to have the next version of GPT? Well, it's the tech companies. So Canada and European Union have the advantage that they don't have as powerful lobbies for tech companies that are absolutely, dominating within the United States, because they dominate not just because they are the biggest lobbyers now, but they also dominate completely the media landscape. All of the major newspapers are complete techno-optimists in the United States. So it sort of creates a very strong ecosystem of going in the direction that's beneficial for the tech companies. So, but therein lies the dilemma, which I think you were sort of mentioning. So yes, Canada, European Union, they can be much more rational in terms of tech regulation and at the forefront of technologies to protect workers, precisely because they don't have the same powerful lobbies and the same powerful companies. But if you don't actually create the technologies yourself, at the end of the day, this is going to be mostly talk and mostly regulation without the actual investment. So it is, therefore, the next stage has to be, both in Europe and in Canada, well, let's put this in practice. Can we create a tech industry that has better values and has a better direction than the US? So I think that would be the real powerful mix.
Let me ask you one final question. We have a question from Ezra Miller. He says, thanks for this really great presentation. A lot of government regulation has tried to deal with some of the issues that you raised. If you were to focus regulatory effects in one specific area, what would it be?
So in Power and Progress, Simon and I say that the most important thing is to sort of have a change in the general discussion of AI. So if we achieve a step towards recognizing that it is both technically feasible and socially desirable to have pro-worker AI, a direction of AI that's going to help workers, help the democratic process, that's already a big success. But that's a first step. The next step has to be, actual policies that will make that happen. And there are no silver bullet policies. There isn't a single policy that would do it. But I think there is a suite of technology policies that would be very useful. First of all, we need to have worker voice. So pulling back from the anti-union, anti-labor organization policies is very important. We need to get rid of the distortions that exist in the tax system. In the United States today, and I think Canada is not as bad, but similar, you get a big subsidy if you invest in machinery to replace labor. And if you hire labor, you have to pay a lot of tax. So in my work with my co-authors, I estimate the tax that you jointly pay for hiring the workers about 30%. If you hire a machinery, it's less than 5%. So that's a big inducement to automate work. So it's an artificial inducement. We can get rid of it. But there are also other, I think, more active policies that we need to consider. One that I think is very important is digital ad taxes. A lot of the ecosystem that's supporting this AGI dream and the tech industry comes from collecting data and monetizing data through digital ad taxes. And if you look at the sort of going back to your first question, Sherry, about why we live in such a disinterested world where people are in their bubble. Well, that's very much about the social media ecosystem, which is completely fueled by this digital ads and the attention economy. And the digital ads ecosystem also makes it very difficult for companies to target other things, because you cannot compete against a company that's providing zero prices and monetizing everything through digital ads as a new startup that says, I'm going to ask people to subscribe and I'm going to ask people to pay me a large amount of money. So in the interest of, I think, creating a more competitive environment, we have to discourage this monetization model being the only way the new technologies are monetized. And if you look at OpenAI and Microsoft, that the main way that they have come up with monetizing this is also through search and through digital ads. So I think a meaningful digital ad tax would do a lot to change the dynamics of the industry.
I want to thank you for this fascinating talk and ask you, do you have final thoughts to share with all of us?
No, Sherry, thank you very much for these excellent questions. And it was really great to be able to talk a little bit about my work with Simon Johnson and other co-authors. And thank you to all the audience members who have asked such excellent questions as well.
Yes, thank you. And thank you to everyone in the audience today.